All right. Well, welcome everyone. Glad to have you here. And we're kicking off kind of like the revival of these paper review sessions. And we're starting from a session that is basically a first experiment of having a feedback loop of our internal researcher agent. That is basically a bunch of code that we worked on that recommended a series of papers for us as a group to review. And then we posted those in Slack. We voted with our human in the loop procedure to pick which papers we're going to discuss. And we landed on those two papers that you saw in the invite. And the first paper is exploring augmentation and cognitive strategies for AI-based synthetic persona. And the way we typically do these sessions, we kind of open up a floor to people that read those papers or skim through those papers, have ideas and want to discuss kind of like a first thoughts or fascination or criticism of papers, whatever you feel like. I'll start with my own kind of introduction into my perspective on the paper. It was actually a pretty cool paper for me because it introduces the data augmentation in a less traditional sense than I'm usually using that term. And it was also fascinating to see the use case that they've produced, that they tested on, which is the Van Gogh, and asking why he cut off his ear, which was an interesting kind of like an open-ended question to even start experiments with. So that was fascinating to me. I really like the overall approach of how do we actually create or synthesize the background for the LLM to have somewhat grounded perspective, because we nowadays treat LLMs as kind of like the ultimate knowledge source. And even though some people understand, or some people in the industry talk about how, yeah, this is not really a database, this is like a compressed parametric knowledge, so we can't expect any kind of like accurate perspective coming out of it or factual. And that's why all the RAG and retrieval augmentation techniques exist. But in this scenario, the data augmentation really comes from the perspective of how do we create the grounded environment for the LLM to actually have some perspective versus a generalization of all the knowledge and things around it. So that's kind of like my long intro into it, and I recommend for everyone that who wants to speak up to raise their hand. Here in Zoom, you can do that at the bottom. But yeah, the floor is yours, Daniel.
Yeah, the timing on this paper is amazing. I'll throw some quick links into it, but we've been working with really light prompt-based simulation training. I'm really keen to dig into this episodic memory graph approach that they've taken to, rather than simply doing a traditional retrieval from embeddings, trying to simulate a little bit closer to how human retrieval works. And yeah, I'm thinking especially in situations like simulation training, where you may have detailed scenario knowledge that you want to have consistent, that a person has in mind. This seems like a wildly interesting approach. I was intrigued by the examples that Steve gave of the different responses that were given from the different approaches that were taken just on the retrieval side.
Yeah, I think you bring up a good point from the actual practical use cases, because it's one thing to write a paper about like, hey, Van Gogh is explaining why he cut off his ear, and I think this is what the academia in general has a problem with in general, kind of like having these abstract situations that look very cool, but how do we apply it in real world environments? And I think simulated training is a very good example, especially as we're talking about how the next generation of our society will have to train how to use AI and how to work with AI, and that assumes that there's got to be some ways to train people the same way as you go to school and kind of like learn to interact with kids and teachers and the hierarchies and the social norms and values. The same way you're going to be doing that through AI. So simulated environments is a fascinating topic. I recently met a girl here at Stanford, and she's doing PhD, and she did like GPT teacher, basically a simulated environment for teachers to learn how to respond to various questions in the classroom from students, which is a great showcase of how you're almost taking on different personas, like the student, and you're simulating what a typical student would be confused about, which is actually a pretty good scenario for LLMs to tackle, because in general the probability of questions that students ask is quite, I would say, there's a normal distribution for sure, which also builds up on the second paper that you may or may not read, but LLMs are pretty good with the normal distributions in general, which poses a very good kind of like environment for simulating these types of questions. Anyone else?
I have a question.
Go ahead, Randall.
I just wonder what this sentence means. To improve LLM performance, new memory frameworks should model information retrieval in a way that mirrors how humans dynamically access memories during interactions. Does anybody know how humans do that?
I mean, it seems like a couple of the insights that he had around it were that piece of adding to normal retrieval, the piece around emotional valence and affect, and the piece around spatial coordination, so that it's prioritizing things that relate to the primary memory that gets drawn on from RAG by ones that have a similar emotional tone or that have a similar geographical location, which to me tracks pretty well in terms of how I remember things.
I agree with you, Randall, that that's a very kind of like ambitious statement to claim that we know how people do that. But I also agree with Daniel's point that, hey, there's multiple dimensions that human mind probably utilizes when retrieving things. Especially, I'll give you the example where LLMs I've seen perform really bad in commercial environments, where you do the vector search and you kind of like do the memories, you stack them up, and then when the situation arises, like for example in personal coaching, and LLM has to retrieve a memory that relates to, not drinking enough water or something like that, and it retrieves the memories that relate to like 6 months ago, where the person had some situation, and it's completely relevant, because there's completely the timing component is missing. Also the emotional component is super contextual. So that's kind of like what I like about the paper, which is a very reductionist way of thinking about it, but at least it gives us some framework. I would love to hear your thoughts, Sid, coming from the neuroscience background.
Yeah, hi. I'm sorry, I'm outside like in a CVS, so there's sound, but I'll quickly say. So yeah, all of this is great, and what Daniel said, like that the sorry, I just called back because I'll come back in a bit because I have to pick up the medicine.
All right, Osama.
Hello, everyone. Yeah, so when I was reading the paper, one of the main things that came up to me, Van Gogh is a historical figure, etc., and we are talking about data augmentation in LLMs, and I was waiting for a word to come up in the paper, which it didn't, which is bias. Whenever there is data augmentation, we are talking about, okay, what is the data provenance in this model? How would it be sourced? Especially when we are talking about historical figures, I'm sure there are some controversial historical figures, or there are some, especially some questions like, why did you cut your ear? Maybe he would disagree with the LLM about its answer. And so the source of the RAG or this model would be, the data provenance would come from biographies, maybe from works of art, etc. And so the challenge with applying data augmentation is that that bias can be further augmented. It can be further propagated, and then you would have to differentiate between what's real and what's not, especially the data can be plagued in a way, and it can be even further to deal with. Of course, maybe there would be some bias mitigation mechanism implemented somewhere in the data sourcing or in the pipeline, but that was pretty interesting that it was not mentioned, and maybe it was not the scope of the paper.
Super interesting. I actually agree with the fact that this is a separate topic of research, and I'll take a controversial position that sometimes we actually need that bias, and it's actually super useful in practical applications. Because if we think about when I was reading paper, my first thoughts was about how do we actually tinker with it and apply it in our environment, let's say researcher agent, and being able to take a perspective, of Arthur or Daniel with unique backgrounds and life journey and, our experiences gives a completely different way of looking at which papers am I interested in, or what are the interesting things in that paper from my perspective. For Daniel, it was like, oh, simulated environments because of like practical, cases that he's working on. For me, it's like, oh, how do I apply it for a researcher agent? For someone else, it could be different. So I think it's actually there's constant pros about the bias. It's not a trivial thing. Sid, you're ready to speak?
Yeah, hi, yeah. Sorry for that earlier. So quickly, two things. One is when the memory is formed in the hippocampus, the information flows in what's called the entorhinal cortex, and that's what's called the grid cells. And hippocampus is the places. Essentially, what they do is they put a space-time tag on the memory. So when the memory is formed, there is a space-time tag. And now, yes, like you want to get contextual and related in space and time. The other thing is that about the valence and the salience, that is really important. So we have what's called the default mode network. This is a constantly like circulating pattern of activity in the brain, which is predicting what the world is like. So there's a lot of prediction that's constantly happening, and memories are matched to those predictions. Okay, this is what it must have been. That involves a part called the anterior cingulate cortex in the front of the brain, and posterior cingulate cortex. One does the location and one does the emotional valence. So, and hallucinogens, psychedelics, basically they weaken that default mode network. So now you sort of get all sorts of different kinds of memories. So I was wondering, first of all, like, is there an equivalent of that prediction system that's can be built into a system like a default mode network? And if there's an equivalent of putting the spatiotemporal stamp on the memory when it happens and matching it. Yeah. Yeah, that was my thought.
That was an interesting, neuroscience perspective. Hopefully that also gives Randall some food for thought from his medical perspective. Yeah. Anyone else? Slava?
Hi, everyone. So first of all, well, it's interesting paper, of course, but I was really puzzled about episodic memory graph system. I don't see graph here, honestly. I don't see any kind of relationship that they extracted and they connected something to something. And it's a bit, I think, weird to call it like graph system. Well, probably I'm mistaken, but this is really essential also about discussion about data provenance. So what they do, they're basically collecting a factual source, and after using this factual source to fit inside of LM, constructing query and constructing context. So it's really dependent on the data quality. So I don't see any information from where data is coming. Yeah, so I completely agree about data is being like basic for this kind of research, and data quality basically defines how LLM will respond to you and what it will do. It will give you what kind of information also. So that's my perspective.
Thank you. Yeah, I was also in a moment excited about like episodic graph, and I was looking for, oh, show me the graph, like what's the connections, the relationships. But I get that they oversimplified this for the purpose of the paper and kind of like called it the graph, and maybe in the next research they'll do it. But yeah, I agree with you. Anyone else? Malavika, I'll prompt you. I know that you skimmed through the papers.
Yeah, thanks. I did. I was actually struggling to find the raise the hand button. And I was waiting for a pause, and I'll just talk. I can't find the button because I don't use Zoom anymore, so I've really forgotten the interface. I thought it was a very interesting paper in that it points to some interesting points, such as the links to the cognitive memory retrieval process in humans, which I think has also spiked some interesting discussion over here, which at least is something that in typical LLM academic work, we don't tend to look at too much. And that's something that interests me as well personally, the links between LLM modeling and the cognitive, actual human cognitive processes on. So maybe this is a little bit tangential point, but I don't know if there are others who are interested in this. But one of the things I'm interested in terms of future research is how can we make use of LLMs to study how human cognitive processes work, to the extent that how much, based on what we already know about how human cognitive processes work, if we're able to simulate that sort of processing with LLM architectures and LLM retrieval processes, how do we use the LLMs to study as to early prediction of maybe some kind of cognitive diseases as such in humans? If we can predict them, if we can learn how to predict them with LLMs, can we transfer that to known cognitive processes in humans? That's something that's interesting, and I thought it was nice to see that there are some people who try to have that link between LLMs and retrieval, human retrieval processes. But of course, I don't know to what extent is already understood by us. The I'm not sure I'm very convinced with the paper's methodology, to be honest. It is, I would say, it's of course a workshop paper, so one can't be too critical. But it is a bit lacking, I would think, on the evaluation side. They have one cherry-picked example, and personally, I'm not very sure from reading the example what their system is adding to the baseline LLM response. I wasn't very convinced. And without quantitative numbers of evaluation, it's hard to say. There are a lot of factors that come into, like some simple question like why did Van Gogh cut us here? The bias impact, the bias factor that someone pointed out and such. So it'll be nice to see if they extend this work into some quantitative analysis, to what extent the retrieval stuff they've added is actually adding value. We don't know how accurate the the Valence score things they've built into are. So is it actually making it worse, or is it actually improving? So it seems the ideas are very interesting, but the quantitative evaluation is lacking, of course. So I'm not super convinced that their methodology would really work. But yeah, those are my 2 cents.
You bring up a good point of the quantitative evaluation and the value of this. Obviously, the use case of knowing why he cut off his ear is a very made up example. When I'm thinking about it in a practical environment, if we would say have a researcher agent that would be able to take on a persona, the actual evaluation would be the usefulness of the interaction to the end consumer, right? And that's also hard to quantify. So it's kind of like qualitative assessment versus the quantitative, unless we do it at scale and kind of like rank the amount of, I don't know, papers that it suggests, or answers when you chat with papers, or use cases like that.
Yeah, that's true. It's quite a hard evaluation. It's hard to build a metric into it unless you've actually captured what a particular persona is, and then you know to what extent you're able to simulate.
Awesome. Does anyone else struggle with finding the raise hand button? If so, just speak up without the hand. Sid?
Hi, sorry, I'm outside now, but I just wanted to respond to that last bit about the cognitive part. The reason, going back to what I said, that our prediction is happening from this default mode network. And when that is disturbed by hallucinogens like LSD or psilocybin, then we hallucinate, and especially with LSD. So the answer is to not to see like how cognitive processes are, if they're similar to LLMs, is to replicate that. Like, can we induce hallucination, and is there a sort of prediction network that's going on constantly, is trying to predict, and can we perturb that? Therefore, we would have something that's similar to our cognition. I just wanted to add that part. Yeah.
Thank you.
That's
Ed?
super interesting.
Oh, you wanted to respond, Lag?
Yes, hi,
No,
hi
I
everybody.
just wanted to
Oh,
say
sorry.
that's so interesting. That's it.
Go ahead, Ed.
Okay, hi everybody. I just I sort of was accidentally invited to join this group, and I come from a perspective of healthcare communications. I spent most of my career at the University of Maryland Medical System, running web services, communication, and marketing, digital marketing programs. And I'm very interested in how this can apply in the medical and clinical field. I think there's lots of opportunity for very well-defined and controlled personas that a physician could use in communication to his patients or her patients. And so this is what really intrigued me when I got the invite and I read through the papers about how that could potentially apply.
Awesome. Daniel?
Just riffing off of what you're saying there, Ed, and Arthur, the piece you were talking about before about the importance of bias as well, and the ability to make potentially a system that can do that, where, for example, it can switch between when it's having a single system with a unified database, but that can talk to a researcher, a GP, and a patient and their family in appropriate context, but grounded in that information that's there. It's really intriguing, yeah.
That to me is the huge opportunity. I view this whole, even the somewhat trivial things of taking a physician's notes about an encounter and amplifying it and distilling that into different types of readable formats is extremely powerful in the medical arena. And I think that's just only now beginning to be, to be explored. But I think the next step is for that physician to be able to present themselves through a programmed AI and to have conversations with patients on an ongoing basis. I talked to my wife about this, and she said, it's really important, my physician's personality. And I like my physician. I like the way my doctor communicates, and to have essentially an avatar that can communicate in that same way would be very, very engaging. So don't have any answers here, and I'm certainly not as technical as you guys are, but I find it fascinating, and I'm very excited about the future.
Randall, go ahead.
Yeah, so this reminds me that there probably have been papers that have been published that indicate that large language models can be more empathetic than actual human physicians, and that large language models could be used to teach physicians how to be empathetic. So yeah, I agree that I think the use cases here for communication at in different contexts and at different levels would be really huge. But another thing that bothers me is that I don't think that LSD would be the right way to think about hallucinations. It seems to me historically that when neurologists try to understand how the brain works, they look at cases where the person has an injury that produces a deficit. And so from that injury, they deduce that the brain performs the missing function because that part of the brain has been injured. So if you have a stroke and it hits your motor cortex, you become paralyzed on one side. So the analogy here, I think, is Wernicke's Korsakoff syndrome, which is alcoholism induced condition where you confabulate. And I noticed the paper doesn't want to use the word confabulate. They want to use the terms that there's a mismatch in memory. But it would seem to me that the medical condition that correlates to hallucinations is Korsakoff syndrome, where the individual just makes up things. So I wonder what Siddhartha's comments would be about that.
Yeah, I learned something new when I read that paper about the autonoetic consciousness. I actually dived into the Wikipedia page and learned about this whole connection with the parietal cortex and how it's involved in like the errors and changes in personality. So I agree with you that probably LSD is a good model for referring to hallucinations as like some random things happening without any explanation. But then there is functional kind of like properties of the brain damage that probably, as you said, the confibulate, the create the different version of reality even. And we see that with psychiatric disorders where even without major damage to the brain, but with some neurological disorders or dysfunctions, personality may change and create a completely different version of reality that may not be true with like narcissistic personality disorder and those kinds of areas. So yeah, that's my thoughts. We have Avi and then Sid.
Yeah. Hey guys. I was wondering how the performance of these kind of models would either improve or tail off as you get kind of larger context sizes. I know like we've constantly been seeing like improvements in just the size of like the context size for like models like Gemini and then GPT-4o. And in some ways it's helped RAG applications where you can kind of put in more just context within the actual kind of prompt itself. But for a lot of applications, you don't even need RAG anymore, where it's like you can just put the entire kind of text space that you're looking for into these models. And I think with these kind of personas, it would be interesting to kind of discuss like how, as you add more like life experience or kind of detail about a particular persona, does the actual use case of like the generation of like a response get better, or does it just like tail off essentially? So
Very good point. I was just at the the AGI house yesterday, and the guys from Israel AI21 Labs were presenting the Jamba model for the hackathon, which is the hybrid architecture between transformers and the Mamba model, which is irrelevant. But they were talking about how the long context models are not really, using that entire context. And there's a new concept of effective context window, where, the model may claim that it's 256K tokens, but in reality, the effective context is probably around something like 50K tokens, which is where a lot of the research goes into needle in a haystack that I highly recommend for everyone to check out and things like that, which means the more stuff we stuff into the context window, the lower probability of accurate, work happening with that context. And there's a bunch of research around that. So I think for some use cases, it will be useful for like personality injection things, maybe some more relevant context to specific situation at inference. I don't know, like to give a very stupid scenario that, the weather may be, bad today or something, and it affects, how you interact with a human being. But for the others where we're talking about long-term episodic, situations or memories, so to say, you can't effectively stuff all of it because the, biography may be actually a lot of tokens. Yeah, so that's my first reaction. Sid, you wanted to say something? All right, then we'll go to Ian.
Sorry, can sorry, I was by mistake. So I'll quickly say, yeah, good point about the confabulation, but I would think it's a bit different, and I'll explain why. So, and the other point about neuropsychiatric disorders. So, there's this whole spectrum. There's a schizoid disorder, schizophrenia, which is very much, people do hallucinate. And hallucination, I don't think is the same as confabulation. Hallucination is when you hear voices, when you see that somebody is approaching you or something. These people are, they will kill somebody. Like they think that this person is going to attack them and something like that. You make up stuff. Confabulation, so one could say, like when you speak garbage, there's a part in your brain called the Wernicke's area, which is in your temporal lobe. And there's called the Broca's area. So one forms a speech, the other actually forms a mouth movements. So there's a band called arcuate fasciculitis. And the thing is that if that sort of damage structurally, Korsakoff syndrome or some kind of structural damage, you will have you can have different kind of damages. In the Wernicke area, if it's damaged, you will say seemingly like stream of reasons, things that don't make sense. But that is not the same as hallucination. Hallucination is specifically either schizophrenia, or you can induce different kinds with the LSD. That this is what has been known, and because it targets this 5-HT2A receptor. So it's a chemical change, not a physical change of a communication system. And I agree, like if you do damage the brain in different ways, things you could replicate. So that's a part of it that I just wanted to briefly say. And yeah, I think like there are these conditions. So bipolar, you said bipolar, switches from mania to melancholia. Like as I say, like Hippocrates said it, like in the Greek times. So you got extreme sadness to extreme ebullience and thing. And maybe there are elements of ADHD, like thinking too many things, hallucinating there. But schizophrenia is what really captures the hallucination part. So I think like when we are looking at cognition, because the brain is a chemical machine and it uses all these chemical systems, and it has got systems that are associated with the most. Schizophrenia is controlling your mood, predictions, and dopamine controlling reward systems. So we can think of it that way, but that of course we are not building a chemical machine. But what we can do at the best is to see like what are these kind of memory systems, how do memory systems work, and how are they perturbed in disease or in thing, and how they can be again addressed. If you give an antipsychotic, they sort of control the, target the HT2A receptor, the dopamine receptors, then you can control the schizophrenic effects. So going back to the thing of how do you correlate? Yeah, that's all I have to say.
Thank you, Sid. I love these, interjections from neuroscience. Like it's fascinating to have AI paper review session where we mention LSD, psychiatric disorders and things like that, because it gives a completely different perspective to things, which I usually don't get here in Silicon Valley, because the AI bubble here is very, homogeneous in a way. Anyways, Ian?
To play off what Randall and Sid had said, in the way of a model, in particular, a dynamically learning model that evolves, not a static one, that through confabulation or hallucination produces falsehood. That falsehood, taken as fact by itself, really results in an exacerbation of that hallucinating or confabulating tendency, which could lead to what you've mentioned, Arthur, more pronounced disorders in the LLM that would have various psychiatric matchups with disorders found in humans, because it starts going down its own rabbit hole of fabricated truth.
Yeah, that makes sense. Randall, you want to respond?
I have another comment. So I wonder if anybody has compared using Perplexity to other large language models. My experience has been that if I start asking questions of Perplexity, it tends not to give me erroneous answers. And the impression that I have is that it's constrained more by the database that it's working with. And so so I'm wondering if that relates kind of to the principles that you're talking about here. So if you gave it a set of constraints and said, use these memories or these historical databases to constrain your answer, is that a way to get improved performance? And maybe another example of it is using expert databases as a source of information for the large language model to use as the reference material to come up with an answer. So as opposed to using the internet or using Wikipedia or using, just all kinds of potentially garbage sources of information, if you constrain the database that the large language model can use to a very expert, refined, curated database, then your answers are going to be more sensible.
Absolutely. The issue of clean data sets is definitely the hot topic right now, especially since, here in AI bubble, the quest is to build the AGI, the utopian, all-powerful super intelligence. And the goal is to absorb all the data and, use as much compute to strive for that, which is definitely producing all kinds of weird things that we're observing. Vijay, you want to comment? We haven't heard from you today, so I'll let you go.
Yeah, I just thought it was interesting what you were talking about earlier with AI-21 and their Jamba model, using Mamba and regular attention together. And when it comes to hallucinations and RAG, I guess one of the questions I had would be whether or not it's more effective to place the question at the start of the prompt that's given to a model rather than to the end. Given that because you're running this in a sort of recurrent manner and you're keeping track of a state, it might be easier to know what sort of information to keep if you already know what you're looking for, rather than if you're just given a chunk of information. You have to know the sort of relevant information in that, and then only afterwards can you ask the question that will extract the real important stuff. And it's a little bit off topic, but just, yeah.
Yeah, but it's actually relevant in my mind, because when you are injecting, let's say, those like biography type of episodic memories and things like that, the actual attention mechanism and the architecture of the model matters, because of how you feed that data, how you tokenize the data, all of these things. So yeah, relevant to me. We have Simone joining us.
Hey, can you hear me?
Yes.
All right, awesome. Well, thank you. This is the first time I'm attending here, but I really appreciate the session. And I just looked at the paper right before the meeting, so forgive me, I didn't read it in depth. It's just reminded me of, since we're comparing this a lot to, how humans work, and we're trying to learn from that and enhance the algorithms. It reminded me a lot of, humans are motivated a certain way, right? And often you can figure out what motivates a person and then maybe figure out how to get them to do something better or more easily. And so, yeah, I was at the AI safety meetup a couple of months ago, and a woman from the what's it called now, the Center for AI Safety, talked about some research where they tested whether a model actually thinks it's being truthful. And I found that sort of interesting, right? So there's a way to basically, so we're talking about hallucinations, and we're assuming that the model was trying to be correct. Perhaps there's more to research here, and maybe figure out, well, is there a way to, and motivate is such a word, right? So like to incent or whatever, reward, the model to actually be truthful, be accurate, more so. When, for example, from a generative adversarial perspective, is there a way to incent that differently so that it helps with hallucinations? So that was just a thought that I had when I was sort of glancing at this paper.
Thank you. Malavika had her hand for a while, but then Rishi.
I just had a couple of points to add around the discussion with the prompt size and the context length. I guess there are a couple of things over there which add to the problem, which I think is still an open research question. One is that as you shove more stuff into the context, there's a tendency for the model to be confused about what is the most relevant aspect, which is, while for things like biography, where you're assuming that all of it is sort of relevant, there are cases where, in say few short learning, in context learning examples, where you give a few examples of what you want the model to, the type of behavior you want it to simulate. And then you find that actually the model is getting confused between the finer context that it's supposed to make use of and the context from the examples. So there's a little bit of uncertainty as to what part of the context the model is paying attention to. And the second uncertainty that arises, I guess, is we're still not very clear to what extent the model is actually paying attention to the context itself, as opposed to relying on the internal knowledge stored in the parameters. So those are two, I guess, important aspects for us to untangle before we're able to use the prompts more effectively, I guess.
Yeah, makes sense. Rishi?
Yeah, so I have a few comments, like fascinating points and discussions, especially from the neuroscience background. And since I am at Google and trying to like build RAG systems there is a very interesting connection between what Siddharth mentioned about the fragmentation between the memory retrieval and the actual generation, right? Like there's a connection which gets severed or disturbed with LSD or other psychedelics, that even if you retrieve the correct memory, you tend to speak like nonsense, right? So basically that is a decoupling between retrieval in the RAG, like retrieval, and the generation part. And what I'm seeing in the research community now is that the researchers are basically evaluating each individual component separately, right? So like you have a RAG system, you have a huge database of memories or facts or whatever. What matters is the retrieval, the correct retrieval. Also, what matters is the format of the stored facts, right? It's not just a database, but it could be a knowledge graph of entities connecting with each other with some relation. So that is one interesting comment that I found. Another one I wanted to just like touch is, and I think I'll end up with a like a question to Siddharth. So the comment that is about the context length. I think now the context retrieval from the context, I think, is largely almost like solved, right? Because previously, when the models were 8K and then they went to 128K context length, what people found was in the middle, if the relevant context was in the middle of the entire context length, that the middle portion was somehow like a wormhole or a black hole where the model wasn't able to attend to facts in the middle of the context, which was very interesting. I don't know why, but now I think the needle in a haystack problems, etc., have been solved. So yeah, we can stuff as much as possible in the context, but what then matters is the format of the data, be it in an SQL like database or knowledge graph. But yeah, I wanted to like see what Siddharth thinks of the paper and how it could be improved, right? Especially if the given application and use case is in a medical sort of caregiving role. Like, I'm interested in what more components in the cognitive architecture what would you think is required, and how would you improve the system proposed by the paper?
Sid, you want to go?
Yeah, hi Rishi, thanks. Really great points. So paper, you mean this paper, right? So I mean, my suggestion is, if do we have this thing like a default mode network? Now I don't know as much about how these maybe what the current architectures are. So what the default mode network does, briefly, is that it predicts what the world is like, because you take the amount of time to process sensory input is around 300 milliseconds, which is too little. So all the time our brain is predicting. And if you think of it like a country, say USA or India, whatever, one of the things that makes it successful is this whole prediction system, or the stock market. How well can you predict? So you spend, like, a brain uses 20% of its energy on that, and countries actually spend a lot of energy just and GDP and everything just to predict. So what currently we have LLM is that we have a system. We retrieve information, we ask it to predict the next one, which is fine, but it's not running like it's what the default mode network is constantly running this thing. And yes, you're right. So there is what's called the anterior cingulate cortex, which is the part of the default mode network, is assigning like the emotional salience and the valence, like how important it is, etc., etc. Then that information, when you want to speak, goes like it'll go to the Wernicke's area, which is forming the sentence, and then it goes to the Broca's area, which will open the mouth and everything. So if there's a Wernicke's area, then you will, but your retrieval might be correct. If there's retrieval problem in retrieval from the from the default mode network or the hippocampus, wherever the memory has been recovered, then you have got the decoupling, and that sort of decoupling is happening more in, say, LSD and psilocybin. Like you're decoupling that default mode network. Now you no longer can predict, and now you no longer you're predicting wrong things, as opposed to like the RAG part of it is which I'm trying to understand. So is there a RAG component to a trained model, and where it is in terms of like what's happening in the brain. So there's the default mode network, which is constantly predicting. There's the hippocampus, which is responsible for memory formation, and memory has to go through the hippocampus, otherwise you will not form a memory. And episodic memory specifically, there are other kinds of memory that can form, episodic or semantic, like for the meaning of things or where it happened. And when you have to recover it, you have to again go through the hippocampus. Again, if hippocampus is damaged, you can no longer recover it. But the hippocampus is not the only thing that's in this whole default mode network that is constantly trying to see what could be happening and happen to the hippocampus. So yeah, that's I don't know how to replicate that, but sorry, yeah.
You were breaking up a little
That's
bit.
what I have to say.
Yeah, I think the default mode network predicting the future world state and that helping our decision making in the current state is super fascinating. And I think models like Sora and Kling and whatever, they are essentially world model simulators, right? And now, given the new Luma Labs Dream Machine, people are giving it one image and the model can predict the next few seconds. So like can we like use those models as a world predictor and then use whatever the state it predicts as a decision making inside
Um,
an agent? That would be fascinating.
So the only thing that I find difference is that the default mode network sort of is a permanent kind of oscillating permanent kind of thing. It goes on and on and on, even if you're not doing anything, not thinking anything, not asked to do anything. It just constantly makes these simulations. I mean, that uses 20% of your body's energy. It's just you're daydreaming or doing something, even if you're sitting on the couch doing nothing. But an LLM, you are asking for it, right? Even if it is predicting ahead of time, it's trying to find a bigger horizon. So I don't know if it's the same there. And that's what makes it living. I mean, if a machine is constantly sitting and thinking and this and that, then hey, I mean, that's living.
And causing anxiety, I guess. But yeah.
Yeah,
Exactly.
anxiety. So the one way to look at it is that people are prone to anxiety, and then if you inhibit that,
You were breaking up. Can you repeat that? Sid, you were breaking up. Could you repeat that?
Hi, sorry, I got a call. Did
Got it. I think the questions of the world model are super important because we're talking about not just ability to predict next token, which is pretty much what LLMs do. There's no I mean, there is an inherent world model in terms of what to say, but not how the world behaves. And there is research about that. Some people claim to say there is a world model, and that's why there is a boom in actually robotics right now, where all of a sudden, researchers and all the big tech is trying to connect LLMs to robots in real life, which is, an interesting direction. But, the Sora model could be a visual world model, but is that the only dimension that we need? That's the question, because I think this paper actually brings up a good point, that there is a unique perspective, a unique world model from the perspective of that individual that is a completely different thing than the generalized world model of how things work. Because for Van Gogh, the world is different. For him, it made sense to cut off an ear, for whatever reason,
I think that's why the personal AI devices like say Rabbit or whatever, they'll be useful in creating an internal state, the current state given all the context in the past, and that could form a good uh, like a fertile grounds for creating a world model for that particular person, which can predict the next state.
Yeah. With that, philosophical kind of note, I'll be wrapping up this call. I think it was an amazing call with so many different perspectives. I hope you guys enjoyed it. Unless anyone has any, finishing thoughts, we have 2 more minutes. Oh, Rendell? Go ahead, Rendell.
I just wonder if there are mechanisms that computer scientists can employ to make large language models hallucinate more. And what exactly are
We've
those?
done that, actually. So within polyagent community, we've built a model that completely hallucinates by accident. Because we're doing the research work on how to fine-tune models to speak underrepresented languages, which is pretty much everything but English nowadays, sadly. but we fine-tuned model to speak Ukrainian, and then we went deeper and built a custom tokenizer, and then froze the weights of the model, and then pre-trained the embedding layer, which resulted in a very consistent, beautiful Ukrainian language without code switching or, Chinese characters in it, but it completely hallucinates. It's almost like a model from a parallel universe where it says things that make sense, and you almost question, like, it tells you about the movie that never, got created, and you're like, you know what? Why no one created this movie? Like, it actually makes sense. So yeah,
Yeah, but
it's possible.
to make the analogy to traditional medical history, that if you want to understand what's going on, you look at how can you damage the system to make it malfunction. So if you remove some component of the large language model, or you impair it, and it hallucinates more, then it tells you that that's important to prevent hallucinations. So you could look at a way of attacking the large language model to damage it, to inform you to how it successfully does not hallucinate.
I think you actually brought up a very good, thought process for us internally to think about. Rishi?
Yeah, I can. So I have perspective on the brain damage, sort of, right, or lobotomy, right? So there's this whole field in deep learning called compression, neural network compression, specifically pruning techniques, where if you think of a large language model as a collection of neurons, similar to in our brain, there's this whole research field which wants to compress this large language model by removing connections and neurons, but still keeping the quality of the model. But as you mentioned, like, obviously, if you don't do it correctly, it will lead to a damaged network and may cause hallucinations or even incorrect results. But we don't need to do this damage. We don't need to do this surgery to create more hallucinations, right? Very simply, even in like ChatGPT or Gemini, these models, which they claim to be like really good, you can, so there's this parameter of temperature where it basically samples, it determines the distribution of sampling the next token. So if you like increase the temperature, that creates more like creative like outputs, which might be more hallucinations, right? And if you decrease the temperature closer to 1 or 0, it's more grounded, more straightforward. Yeah.
Yeah, but it also brings up, the temperature really, at least in my experience, it just makes the model more deterministic, in a way. Doesn't
I
mean
mean,
hallucinations.
deterministic might not be the best way, but so I mean the mathematics. So I can go why it does that, but yeah, basically, so at the last layer of the model is basically it tries to select from the vocabulary, say whatever, 200,000 words in English, and that temperature sort of changes the probability distribution of which is the best next token. So yeah,
So is temperature just a synonym for creativity?
sort of, but also yeah, like you
Climate
can more
interject.
predict.
You increase the temperature, you increase the creativity. If you increase the temperature too much, you just go crazy.
Yeah, sort of. Also,
The
like
way I think about, oh, sorry. I just want to quickly add, the way I think about the temperature is just so it softens or sharpens the probability distribution. So I can never remember whether increasing softens or sharpens it, but essentially it's just when one says that it makes the model more creative or diverse, all we're saying is that mathematically it's just making it more likely to pick a token or a word which in the model's probability distribution is not actually right. So it's like if you know that after a noun you'd have a preposition, for example, really bad example, But if you know that in general after a noun you'd have a preposition, if you tune the temperature, the model's less likely to pick a preposition. It might just pick something else at random. So essentially, it's like increasing the randomness of what you get, which sometimes helps you get more cohesive but diverse responses. So it's I don't know how useful, going back to the original discussion, I don't know how useful the use of temperature is to generate more hallucinations. But what I was thinking of based off of what Randall said is one way to investigate hallucinations better is perhaps by playing around with the prompt token itself. Keep the temperature consistent, but just, which is, I think, one recent work that Google released out, where they just kept shoving the same sentence several times into the prompt. So you have the original question and an answer, but then they just kept shoving one of the wrong answers repeatedly into the prompt, and then found that at some point, the model just, even though it had the correct answer initially, it just drops off. So it playing around with the prompt, I think, is like a nice way of figuring out at what point the model starts hallucinating. But it's a cool idea from Randall. I think Google's going in that direction, it seems like.
Awesome. All right, we're 5 minutes over, so I'll be wrapping this up. The last words would be for anyone who haven't joined our Slack, you can go to our website, polyagent.co, click join community, and we'll onboard you. And I'll highlight that we are working on this researcher agent kind of internal project, which is essentially recommending papers for us to discuss here. And then in the future, the next step is actually to create a system that transcribes these calls, picks out the things that are interesting to us, the things that we're talking about, and makes a feedback loop into that researcher agent to kind of like influence, create a bias of a sort about which papers we are interested in. So that's kind of like the highlight of the work that happens in Slack. And with that, thanks everyone for joining in. Hopefully everyone enjoyed it. Bye-bye.
Bye, everyone. Thanks.
Bye. Thank you.
Bye. Thanks.
Thank you very much. Bye bye.